Well, hello everybody. This is the shared work problem from the final exam study guide. Shared work because we have a community water tank that's going to be filled by two different wells. And the first well, the town office well, could fill the tank by itself in 18 hours. And the second well, the high school well, could by itself fill the tank in 22 hours. Well, we're going to have them both fill the tank at the same time, and we want to know how long it's going to take. Now, my technique is to get knee deep in a problem before you run to the pencil. And so let's actually think about this. I set it up as a multiple choice problem because it will be a multiple choice problem on the exam. And I'm not saying that we could solve it this way on the exam, but certainly with the numbers I've chosen for A, B, C, and D, if we think about this, we can solve this without doing any algebra at all, just by getting knee deep in the problem. Now notice they both take about the same amount of time. 18 hours and 22 hours are pretty close. They're working at about the same rate. This one's filling it a little bit faster, but not that much faster. And so, if they're both working at the same rate, when they work together, it should take half the time, right? So the answer is going to be somewhere north of 9 point something, or maybe 10. And when you look at these answers, this is the only one that's close to that. And so without doing any algebra, just by plunging into the problem and thinking about it, I have a pretty good idea that the answer has to be 9.9 hours. Well, of course, you want to know how to do this using algebra. And I know in the section on shared work, there's a formula for this type of problem. I don't really believe in formulas. I believe in thinking about a problem and finding the answer that way, using algebra. Now, I always set up a sequence for these things to get the ball rolling for myself. Now, we know that the town office well takes 18 hours to do the job. And so in 18 hours, it'll do 18/18ths of the job. It will do a whole job. In 1 hour, it'll only do 1/18th of the job. In 2 hours, only 2/18ths of the job. The key here is this idea of letting T be the time when working together they finish filling the tank. And so in T hours, the first well, the town office well, is going to do T/18ths of the job. And we run the same argument here for the for the high school well. In 22 hours, it'll do a whole job because it takes 22 hours to do a job. And just to make sure you're with me, you can actually imagine going forward, letting this well run for 44 hours, in which case it would fill the tank twice because 44 divided by 22 is 2. But, of course, we're not going to let it run that long. In 1 hour, it will do 1/22nd of the job. In 2 hours, 2/22 of the job. In T hours, it would do T/22 of the job, where T is the amount of time working together. They do a whole job. And the key there is they're working together, so we have a straight addition here, and they're going to do a whole job. So there's the equation right there. And I didn't memorize any formula, I just sort of thought my way through it. And so what we have here is this equation, which is a rational equation. T/18ths plus T/22 is equal to, and we want them to do it one whole job. So that's the rational equation you want to solve. And I'm going to go ahead and use my technique of wouldn't it be nice. In other words, I'm going to create some elongated fractions here so that I have room to store my factors. And I'm going to play this game, wouldn't it be nice? Now, notice over here we simply have 1 over 1. And the game is to clear fractions because we have a rational equation that's quite easy with this technique. Now, I'm going to factor 18 into its prime factors. That's 2 times 9, and 9 is 3 times 3. So the prime factorization of 18 is 2 times 9, or 2 times 3 times 3. And 22 is also easy. I don't need to make a factor tree. It's going to be 2 times 11, and both 2 and 11 are prime, of course. And so I've factored the bottom of both of those, and over here there's nothing to do. And so now we're going to play this wouldn't it be nice game. And wouldn't it be nice, for example, if I had a 2 up here? Because if I had a 2 up there, I could cancel those 2's, and I would be on the path to clearing fractions here. And of course it would be nice, and it's going to be nice, because I'm going to multiply both sides, every term, by 2, including this one. And it's doubly nice because these 2 cancel. Of course, I have to show my multiplication by 2 over here, and I can see I'm going to be cramped for space, but we'll try and make it work. Now, instead of multiplying by 3 and you know, say wouldn't it be nice to get rid of one of these 3's at a time, I'm going to go ahead and multiply by 9. Because 9 is 3 times 3, and that will certainly be nice. Those will both cancel. And I no longer have a fraction here in this first term. Of course, this gets multiplied by 9, and notice nothing cancels here. 9 doesn't go into 11. And this gets multiplied by 9. And so we're almost done. It sure would be nice if I had 11 up here, though, because if I did, these 11s would cancel. And of course, everything needs to be multiplied by 11. Let me just go ahead and borrow this 1 here and make it into 11 like so. So I've multiplied the right side by 11, and once I multiply this by 11, I've multiplied both sides by 11. Notice on this side there's no fraction. There's just t times 11 or 11t. And notice on the right side, on the second term here, I have 9 times t. There's no fraction. And over here I have 11 times 2 times 9. I'll just write it like this in ascending order, just because it is appealing to me, like so. I'm not going to multiply that out, and I discourage you to do that, because where we're headed here is to canceling, and it's nice to have things in factored form. No sense in multiplying them together and then having to factor them again. Here we are now in section 1.3. That is a equation in one unknown where we combine like terms. And then what we do is we divide both sides by 20 here. And of course that's nice because the 20 is going to cancel here, and we've isolated for t. I'm dividing this side by 20, but I'm going to factor it as I go. Now 20 is equal to 2 times 10, and 10 is equal to 2 times 5. Agreed? So that's really just 20 right there. But now I have prime factors. Well, I have factors in the top and all factors in the bottom, and they can cancel 1 for 1. But nothing else is going to cancel here. This is made out of 3's, and I don't have any 3's down here. And so we're done. We have t is equal to 99 divided by 10. 99 divided by 10. When you're dividing by 10, you move one place to the left, so it's not 99, it's 9.9 hours. And that's the answer, pretty much, you know, what we figured out by just jumping into the problem and thinking about it. About 9.9 hours to fill the tank with both pumps working together. Okay, I hope that helps.